Well, hello everyone. Welcome to this Ashbourne Maths video, and it is the second in our three-part integration series. So here is a question, evaluate, and then we've got this thing here, giving your answer in a certain form. Okay, so let's write this in index form. So this is the integral of x to the power of minus a half dx. And we've got these limits as well, which is something that we've not seen yet, okay, and we'll come on to that. So integrating this gives us, remember, we increase the power by 1 and we divide by that power. Okay, add c, and so this equals 2 root x plus c. Now, because we have these limits, this means this is what's called a definite integral. And so we have a slightly different procedure. Firstly, we put some square brackets around our answer. Secondly, we no longer need this plus c, okay, so I'm actually just going to remove that. And thirdly, we put our limits at the top right and bottom right of our square brackets, so like this, 8 and 1. And I'm just going to move this a little closer. And now on to our next step. I then write two sets of brackets, okay, a little bit like this, and I take one bracket from the other. I then fill in my function into the two brackets, so 2 root and 2 root, and I don't include the x. And what I'm going to do is I'm going to substitute each of my limits into these brackets. So this 8 goes where x was, and this 1 goes where x was, and I'll just use some highlighters to show you what's gone where. So hopefully, as you can see, I've substituted the 8 into my first bracket and I've substituted the 1 into my second bracket. Just remember, the order of this is important. The top number needs to go into the first bracket and we take it away from the second bracket, which has the bottom number. Okay, now we're in a position to simplify this. So this becomes 2 times 2 root 2 minus 2. And so I can rewrite this as minus 2 plus 4 root 2. And I have my answer in the format that was required at the start of the question, and I'm done. Okay, now let's move on to the second little exam question. And this question says, figure 3 shows part of the curve C with the equation y equals all of this stuff. And the question at hand is, find the area of the shaded region. So all this stuff that's in grey. Now, this leads us to a really important point, which is what I've written in blue here. Integration represents the area under a curve. So we can use integration to find this area. Now, importantly, we must clarify that the area is between the curve and the x-axis, okay? This is really important. So looking at the diagram, it's the area that's trapped between the x-axis, okay, and the curve. So it's going to be all of this bit here, okay, and in the second part of the graph, it's going to be similarly all of this bit here, okay, the area that's trapped between the curve and the x-axis, okay. It's not going to be this stuff because this stuff here is not trapped by the x-axis. Okay, so how are we going to find the area? Well, we're going to do this in 2 bits. Firstly, we're going to find area number 1, which I've labelled there, and secondly, we're going to find area number 2, which I've labelled here. So let's start by trying to find area number 1. Now, we need to know the roots of this equation. So here's my curve, and so I can tell straight away that the roots are going to be x equals 0, x equals minus 4, and x equals 2. Okay, so I can now come up here and label these on my curve. So instead of A, I'm going to write minus 4, 0 is already there, and instead of B, I don't want that, I'm going to have 2. Okay, so now I've labelled this curve accurately. So area number 1 is going to be the integration of this curve, so the integration of x plus 4, x minus 2, dx, remember that means with respect to x, and I've got some limits. It's going to be between these 2 points that I've got. So this is the kind of like outer limits of what I'm interested in, okay? So between 0 and minus 4. Now, because 0 is the most positive of those 2 limits, I put the 0 at the top and the minus 4 on the bottom. So the most positive number goes as the upper limit. Now, if I was trying to find the area, not between 0 and minus 4, but perhaps between minus 1 and minus 4, it would look like this. Okay, so hopefully you can see that I've changed this area. So now I'm only looking for the area between -1 and -4, and that would be totally okay. My cutoff would be -1 in this case, and for my integral, I would change my upper limit. Instead of 0, this would now become -1 because I'm only interested in the area between x equals -1 and x equals -4. So that's how we would do just a little subsection. But in this case, I want to find that whole area, so I'm going to go between 0 and -4. Okay, let's crack on. So firstly, I need to expand this thing, don't I? So this becomes x times x squared plus 2x minus 8 dx. And this equals, just expanding again, x cubed plus 2x squared minus 8x, all with respect to x. And I've got to remember my limits. So this is 0 and -4, and I forgot that over here as well. Okay, and now I'm ready to integrate. This is something that we know how to do. I must remember my square brackets and my limits, 0 and -4. And so this becomes x to the 4 over 4 plus 2x cubed over 3. Remember, I divide by my new power when we integrate. And 8x squared over 2. Simplifying, this becomes x to the 4 over 4 plus 2x cubed over 3 minus 4x squared. And then I've included my limits again here. Okay, and now we're ready for that bracket technique. So here it comes. Put in my two brackets, give myself enough room. And I'm going to start with the top limit. I'm going to substitute this limit in for all of my x's. Okay, so let's do that. 0 to the power of 4 over 4 plus 0 plus 2/3 of 0 to the power of 3 minus 4 times 0 squared. And obviously all of that stuff is just 0. In my second bracket, I get -4 all to the power of 4 over 4 plus 2 over 3 times -4 to the power of 3 minus 4 times -4 squared. And I'm going to just need to do some very careful expanding here. So this becomes 0 minus, open my brackets, and I just need to be careful. So this is positive 256 over 4 plus 2/3 of negative 64, take away 4 times positive 16, close brackets. And again, let me simplify, just being really careful with my negative numbers. This becomes 64, take away 2/3 of 64, take away 64. Okay, and my two 64s cancel here. And so I'm left with, on the last line, negative 2/3 of 64, which of course is positive 128 over 3. And I've found the area of that first section of my curve, this section 1. Now, let's move on to area number 2. So this, remember, is going to be between, our limits are going to be 2 and 0, so I've got to remember that. So let's begin by writing this down. So this is area number 2, and remember, it's exactly the same curve, right? So I've used the same function, the expansion of the function, but this time my limits are going to be 2 is the most positive of the limits, and 0. Okay, and I can move on to writing out my square brackets again. So I get x to the power of 4 over 4 plus 2x cubed over 3 minus the 4x squared again. And this time my limits are 2 and 0. Okay, and now I can do that same expansion technique. Let's just do this again. So firstly, I'll write my two brackets again, remember, and I'm going to substitute the top limit in first. So this becomes 2 to the power of 4 over 4 plus 2 over 3 times 2 to the power of 3 minus 4 times 2 squared. And then in the second bracket, I substitute in my 0. So this becomes 0 plus 0 minus 0. So again, that's all just going to be 0. Let's simplify this first bracket. So this becomes 16 over 4 plus 2/3 of 8 minus 4 times 4, which is 4 plus 16 over 3 minus 16, which equals minus 12 plus 16 over 3, which finally equals minus 20 over 3. And that is my finished second area. Now, why is our second answer a negative number? I've got my answer for area 1, which was positive, this thing. I've got my answer for area 2, which is this thing, which is negative. Why is that? Well, let's look on the diagram. The area underneath the curve in the second part is actually underneath the x-axis, so this will give us a negative area. However, there's no such thing, technically speaking, as negative area, is there? Area can only be positive. And so, if I want to find the total area of these two sections, so this and this, I need to change this second area to be positive. Okay, so this needs to become positive, and then I can add them together. So I therefore write that my total area is going to be area 1 plus area 2. So this is, well, what did I have? I had 128 over 3 plus the positive version of the second one. So I should say kind of like the positive version of that second one. So this is going to be plus 20 over 3. And so my total area is 148 over 3. And that is my final answer. And I'm done. And therefore I can highlight this. The last thing that I want to say, and I must reiterate, is if you are finding areas under the curve and one bit of the curve is underneath the x-axis like we had here, so this second part was underneath the x-axis, you must consider them separately. So you've got to do what I did, which is you've got to work out the area in two separate chunks. You can't just work out the area all in one go, because you will have positive area, which is this stuff, and some negative area, which is this stuff. And what they'll do is they'll cancel each other out and you'll get the wrong answer. As I said, if you've got two different sections of area, you need to calculate them separately, and then at the end, make the negative one positive, and then you're ready to add them together, which is exactly what we did. We found the two separately. The second one originally was negative and we made it positive, and then we added them together to give ourselves our correct final answer. And that's the end of the video. Thanks very much.